Hello everyone, welcome back to the system design series where we are discussing all the important concepts related to the system design interview. Today we will be focusing on how to design a URL shortener. Before we design a URL shortener, let's first understand what is the need of URL shortener. As per the standard, maximum size of a URL will be 2048 characters. However, nowadays a lot of browsers has extended the size of the URL. There are a number of issues if we have long URLs. Let's assume we have a very long URL and we want to send it via SMS. We can't send very long URL via SMS. If we want to store thousands of URLs in our system, overall it takes lot of space to store the URLs in our system. Manually remembering and typing a large URL is a pain for the user. These are very few issues. There are a number of other issues we have if we are using a long URL. Hence, we need URL shortener to avoid such issues. In this session, we will be designing a scalable URL shortener application which can be used in real world. Before we start designing the application, let's first clarify the requirement for our system. Will the shortened URL be alphanumeric? Will it be of fixed length? What is the load of the system? Are very important questions what we have to clarify before designing the system, because answers to these questions will influence our design. Let's assume as per our requirement we want alphanumeric shortened URL. The shortened URL can be as small as possible. Our system will be handling 100 million requests per day. Once we got all the answers to these important questions, it's time to calculate the back of the envelope estimation. Similar to requirement clarification, back of the envelope estimation step is also very important and you have to do it before you start designing any software system. The reason is same. Back of the envelope estimation will influence your design. Hence, you should know the scale of the system you are going to design. Our system has requests per day of 100 million. Let's calculate QPS from here. QPS is nothing but queries per second, or you can assume requests per second as well. So it will be 100 million by 86400 requests per second. As we are performing back of the envelope estimation or rough estimation, we can convert this calculation as 10 to the power 8 by 10 to the power 5, which is 1000 or 1k requests per second. So our newly designed system has to handle 1k requests per second. Let's understand the storage requirement for our system. Let's assume average large URL size is of 200 bytes and short URL size is of 50 bytes. And in our system, we have to keep short URL and long URL in our database as a map so that we can easily convert from short URL to long URL and vice versa. Hence, in total, we will need 250 bytes to store one short URL long URL combination. So per day we need 100 million into 250 bytes, which is 10 to the power 8 into 10, nearly 25 GB of storage. So every day we need 25 GB of storage space to store short URL long URL map. Please note, here in this back of the envelope estimation, we have assumed all 100 million requests are write requests. Apart from this, there will be millions of read requests along with this. Hope you have realized the scale of the system we are trying to design. As we have clarified the requirement of the system and have identified the scale of the system, we are ready to start with our design. We will start with the initial simple design and step by step we will enhance the design. At the end of the session, we will have a scalable, resilient URL shortener system what we can use in real world. Let's assume we have a single server to handle all the requests. We have users who can send two different type of requests. One is to generate short URL for a long URL, which is a post request, or they can do some get request to get the long URL corresponds to a short URL. We have to design these two APIs for our system. Server will have a database where we have short URL and corresponding long URL. For post request, our server will generate short URL based on the input long URL and then save it in the database. For get requests, user will send the short URL. We have to find out the corresponding long URL and we have to send it back to the user. Hope you have realized what are the two APIs are important for our URL shortener system. Post API can be something like this, where it takes long URL as its request body and returns short URL, whereas the get API will be short URL, response will have long URL. Let's understand how this get API works. Initially, client requests for long URL by providing short URL. Server checks its DB and get back the long URL. It sends the long URL to the client along with HTTP status code 301 or 302. These 301 and 302 are the redirection status of HTTP. Once client gets the status code 301 or 302, client will realize that it has to visit the long URL now. Hope you have realized how HTTP status code 301 and 302 is being used for redirection. 301 is for permanent redirection, whereas 302 is for temporary redirection. Remember, if it is permanent redirection, client will save the long URL in its cache, whereas for temporary redirection, client will not cache the long URL. Hence, every time client will use the get API in order to get the long URL in case of 302 or temporary redirection. Hope you have realized the significance of these redirection status code. However, in our initial design, we have relied on single server. There are a number of issues if we use single server. It is a single point of failure. It cannot handle the scale of our application. Hence, we cannot rely on a single server for this. We need multiple servers. Let's refine this design now. In approach 2, client will perform post and get requests via load balancer, because now we will have multiple servers. Something like this, where load balancer distribute the load among multiple servers. Servers in turn will communicate with the DB for read and write operations. In that way, we can avoid single point of failure, which can handle large scale as well. Remember, for load balancer also, we can have primary secondary load balancer setup to avoid single point of failure in load balancer level. Now we will concentrate on two different areas. One, how servers generate short URLs, what is the logic behind it, and will this single database can handle the load? These are the two questions we have to solve. Let's first start with the first question, which is how servers can generate short URLs from the long URLs. One approach is use well-known hash function. We can use CRC32, MD5, SHA1, etc. algorithms in order to convert the large URL to a fixed size shorter URL. But note that CRC32 will be of 8 characters, output of MD5 will be of 32 characters. Output of SHA algo will be of 40 characters. So obviously we cannot use all of them, because on that case the shorter URL size will be a lot more, like 32 characters or 40 characters. We need trimming. What we can do is we will have long URL which will go through the hash function. We get, let's assume 32 characters for MD5. We pass it to a trimmer. For simplicity, let's assume it will only keep the first 7 characters from the hash value, and we save short URL here and long URL here. However, because of this trimming, there could be a chance of collision. That means there could be multiple long URLs which has common first 7 characters. In such cases, we can use some technique where we can add some predefined strings with the long URL and then perform the hash function so that we can avoid collision. Let's understand the approach one more time. In approach 1, we will be using some well-known hash functions such as CRC32, MD5, SHA1, etc. However, we cannot use them directly because the output of MD5, for example, will be of 32 characters. The output of SHA1 will be of 40 characters. We cannot use 32 characters or 40 characters as our shorter URL. That is not a short at all. Hence, we need to use something called trimmer, and very basic idea is we can only keep the first 7 or first 10 characters among 32 characters generated by the hash function. As we are trimming the hash output, there will be higher chance of collision. To mitigate that, we can use some predefined strings and we can add it with the long URL and again calculate the hash function, which can reduce the chance of collision significantly. In that way, using approach 1, we will have fixed length short URL for a long URL. Though we have some overhead to calculate hash function, trimming it up if there is a collision, add some predefined string with the long URL and perform the hash function again. However, this is a fair approach to evaluate short URL from a longer one. However, as per our requirement clarification, we know we don't want fixed length short URL. Rather, we want the URL to be as short as possible. Let's go to the approach 2 now. In approach 2, we can use base 62 conversion, which can have encoded alphanumeric value where there can be 0 to 9s, capital A to Z, small a to Z. Hence, the output of base 62 will be a alphanumeric value. However, base 62 takes a numeric ID as its input and it converts it into alphanumeric key. So what we have to do, we will get long URL. We can use unique ID generator. If you don't know how to design unique ID generator, I have a dedicated video for it in this same playlist. You can watch it out. Once we get unique ID, which is numeric in nature, we can perform base 62 encoding and we get short URL. Hence, in this approach, we get variable length short URL, which is required for our requirement. Here, the overhead is we have to calculate unique numeric ID for a long URL. Then only we can apply base 62 encoding. However, in most real world URL shortener system uses base 62 encoding technique, what we have explained in approach 2. In our case, we will be choosing approach 2 for our design. So each server will use base 62 conversion in order to get short URL for a corresponding long URL, and it will be saving into the database. In future, whenever there is a GET call we get from client, we can consult this mapping and return the long URL corresponds to a short URL. Hope so far you are with me. Will this single DB can handle the load? The answer is no. We have to use distributed key value store. I will not go into details of distributed key value store because I have a dedicated video for it. You can watch the same. We have to achieve a very less response time for our system. What we can do? We can introduce cache to enhance the performance. In our final approach, client can send both post or get request to the load balancer. We can have multiple servers and load balancer will distribute the load among these servers. These servers will perform the approach 2 in order to create short URL for longer one and save it into the distributed database. We need distributed database because the size of the storage requirement what we have calculated during our back of the envelope estimation is 25 GB per day. Hence, one single database server will be full after storing couple of days of data. For enhanced performance, we can use cache. The cache will store short URL as key and long URL as value. This cache will be used only for GET requests where client wants to know the corresponding long URL for a shorter one. In such cases, our server will first check in the cache if the long URL corresponds to the short URL is already present in the cache. It will return the long URL to the client along with HTTP status code 301 or 302. If cache does not have the short URL we are searching for, server will communicate with the DB as it is a cache miss and get the long URL from DB. Update the cache accordingly so that all the future requests can be handled from cache itself. Let's summarize what we have learned in this session. We realized why URL shortener is required. We want to reduce the length of the URLs. Hence, URL shortener is very popular nowadays. We refined our requirement by asking few clarifying questions. We have performed back of the envelope estimation to understand the scale of the system we are trying to design. We started with a single server approach and realized what are the APIs we need for URL shortener. Post request will be to register the long URL and get the short URL corresponding to the long URL. The other API will be a GET API where client will pass the short URL in order to get the long URL. In case of GET API, we will send HTTP status along with the long URL. Hence, client will realize that it has to visit long URL again. However, the single server approach had issues like single point of failure and it cannot handle large scale. The obvious solution is to have multiple servers. We can have a load balancer where client either send a post call or a GET call. There will be multiple servers to handle such requests and the mapping between short URL and long URL will be stored within the database. In that way, we are avoiding single point of failure and we are making our system scalable enough to handle large scale. Few questions arises from this approach. How server will generate short URL after taking the long URL from the client? Will the single DB be enough to store the short URL long URL mapping? In order to generate short URL, we have discussed two approaches. In approach 1, we plan to use well-known hash functions like CRC32, MD5, SHA1. We realized the output of these hash functions are long enough which cannot be used as short URL. We thought of trimming it off and then create the short URL of fixed length. We realized how by adding predefined string with the long URL we can avoid collisions. However, as per our requirement, we don't want fixed length. We want the short URL to be as short as possible. We jumped into approach 2 where we are planning to use base 62 conversion which will give us a alphanumeric short URL. However, base 62 conversion needs unique numeric ID in order to generate short URL. So in approach 2, though we do not have overhead of handling collision, we have to generate unique numeric ID. However, the output of approach 2 will be a variable length short URL, which is needed for our design. A single database will not be sufficient because every day we are adding up 25 GB of data in our system. In very few days, single database server will be full. Hence, we need some distributed database. And as we are storing short URL and long URL, it's a wise decision to use distributed key value store for our purpose. In order to enhance the performance of our system, we thought of introducing cache, where for all the GET requests, servers will first check in the cache if the mapping is present. If present, it will send the long URL to the client along with HTTP status of 301 or 302. If not present, or in case of cache miss, it will go to the DB in order to identify the long URL corresponds to the short URL and send it back to the client. Do not forget to like this video if you have learned something new from this session. Thanks a lot for watching this video.